Hello there. I'm going to be demoing and going over some code that I created for the classic snake game in Python. So first I'm going to demo it. We have our program here. I'm going to just eat a couple food items and then let it die. And then bam, game over, high score, your score, and you can restart if you want, etc. So I'm going to go over the code. You're only going to need these imports, tkinter and random. I'd also like to mention that some of this code is based on this YouTube video. I think his name is Kenny Coding, or Kenny Yep Coding is his name. Um, that's what the logic is based on. And to run the program, you're going to use py snake.py. And to control it, you can use WASD or up, down, left, or right, and you can use capital or lowercase the way I have it set up. So first of all, we're going to need to set up our columns and our rows for our stuff. So tile size is 25. That's what we're just gonna, that's like a pixel essentially. So 25 times column sets up a 625 pixel width, and then tile size times rows sets up a 625 pixel height. So that's our window box size, which when we run it pops up right here. So we have that. We have our tile class, which this is used for the snake and the food. And then we have our game window. So to set up the game window, you just set up window equals tkinter.tk. You set up the title, which is right here, and then it's not resizable. I don't want it to be resizable because of the concept of the game. If you hit a border, the game ends. So first we do canvas equals tinker.canvas, and we set up our window with, these are all going to pop up when you do it, if you do the command. Canvas equals tkinter.canvas. See all of this, you just need to fill it in. That's basically drawing our window and what we want it to be height-wise, width, the border, the color, etc. And we set that up. We center it. And then with this, we're getting, this is our info about our screen specifically. So this could work on whoever's computer, regardless of the size. And then we center it with this. Set up with window geometry, and then bam, the window's set up and it's done. So we move on to some of our actual logic here. So first we have our snake, and the snake is equal to the location that the snake's at. So we have tile size times 5, which is the location of the snake when it starts, which I can show again real quick. Should honestly just keep it running. I don't know why I'm closing it. But it starts here. This is 5 times 5, 25. Okay. Food, same thing, 10 times 5. Down here it starts here. That's the location of it. So we also have a velocity x and velocity y. Actually keep it open. And snake body, which is a list. And then we have game over, boolean set to false, our score and our high score. So for this to work, you move the snake with keystrokes. So we're going to need this key sim. And the way I did it, you don't have to do it like this, but I wanted it to work for up W or lowercase w for the move controls. So I set up these right here, and essentially the velocity of the snake starts off at 0, 0, and whichever direction the snake's going, or the velocity controls which direction the snake's going. So ignore this for now. This is if the game ends to restart it, but essentially we're getting the key from releases during the loop. Key releases change direction. That's where this is coming from. So we're getting that key here, and then we search through this. We search through this. If the key is one of these, and the velocity is not already in that direction, meaning like if it's going up, you can't make it go in that direction. Like you can't make it. I don't know how to explain it, but the snake game, the way it works. Look, I go left. I can only go up left. I can't just go back left. So you can't just go back left up down. It's a snake. You have to turn like a snake. So I'm going right. I can't just go left. I have to go down and then left, or up and then right. That's the best way I can explain it. So that logic is here. That's why you have the and velocity is not equal to 1. So if it's up and the velocity y is not already up, then you're changing it like this. And same with down, left, right. I don't feel like sitting on the logic for it because it's easier to watch from scratch, which this video does, with this logic at least, this video. But that's the logic for the changing direction. And then we have our move function here. So we have our global variables. If the game's over, we check for a high score update and update it if it needs to be. We have this right here. If the snake x is less than 0, or the snake x is greater than the window width, meaning that it hits one of the borders. Same with the snake y, less than 0, or snake y over the window width. That means the game is over, meaning that you met one of the conditions for the game to end, meaning that the snake ate his own tail, or that the snake hit a border. We have this loop right here. This is looking for essentially, this is tile and snake body. This is if the snake eats its own body, is what this is. This is if the snake hits a border. So if the snake eats its own body, then bam, game over. So we have this as well. This is for a collision with food. If the snake x equals food x and the snake y equals food y, meaning that the snake has encountered the exact same location of a food tile, then the snake body is going to append the location of where that food tile was. And we're going to add that to the list of the snake body, which is currently empty at the start. Oh, where is it? Right here. So, right here. And we're going to re-randomize the location of the food with this right here. It's just a simple random function from pi. And we update the score. So the last thing here is to update the snake. This is updating the snake's body. Basically, we have a loop here. It's a for loop for I in the range of the length of the snake's body, and the tile is equal to the snake body with the loop, and this is just updating it. Then we have snake x plus equals velocity x times tile size, snake y plus equals velocity y times tile size, and that's it for the move function. The draw function, we have our global variables again. We call the function move, which is here. That's the first thing, is the move function. After that, we do canvas delete all, meaning that I can't demo this because actually I can. So this is what it looks like without canvas delete all. Looks normal snake game, whatever. Alright. Now look. That's what happens. So it's constantly drawing the snake body, but it's not erasing. So that's the issue we encounter if we don't have this canvas delete all. We draw our food items, so if we call the move function, we do delete all, we create our food. This is all a loop, by the way. And we do our for tile and snake body create. This is drawing our snake body. So the logic is there mathematically for the snake body here, and a little bit here for appending, and then here. That's a logic for it. But you want to actually draw it here with canvas create. That's what this canvas does. So we create our food here. We create our snake here, the colors here, and then we have this loop for our body that's running. And then if the game's over, we pop up with the score. Okay, the score we put in the center as well here with the window width stuff. The font, the game over score, high score is, space restarts. And then if not, then we just have the score on the top left just constantly updating as the user eats more food. And then this is what actually keeps this going. So after every 100, meaning 1/10 of a second, every like 1 millisecond, we call draw, and that's how this function works. Draw basically is a loop to itself because look, it recalls this every 1/10 of a second. All of this reruns, constant loop. And then we call draw. We have our window bind key release that's listening, and then our loop. So that's the logic for this program. I'm going to demo it again. Once again, I really skim over a lot of this stuff because the logic is already explained in this video for it, and it is pretty basic. The most complicated thing is probably the snake body updating, which he does a great job in this video. I'll keep a link to it as well, explaining it, explaining how that works in this code. But I'm going to do a quick demo again. This is also probably the easiest programming language to do this game in. Python's very easy to get started with stuff like this. They have really helpful libraries. But yeah, I'm gonna cap it off there. Pretty basic program. It's just a snake game. Everyone loves a snake game. Can't go wrong with it. The high score stuff is here. The logic for it. It's in the move function. You can see here, and the boolean of game over is where is it? If game over, here it is. It's a reset here. If the user presses space, all of this stuff is set to false, and you can restart. So that's the logic here. You have to reset all of these variables back to the beginning, except for high score, obviously, to keep the loop running. Because if you keep the boolean as true, then this loop will just end and it won't work because all of these depend on it not being game over. But yeah, that's a code. Thank you for tuning in. I'm sorry if I skimmed over some things. Once again, this video explains it very well. Like, it's a 30-minute video, so it's going to explain it better than like a 12-minute video. But that's the basic logic and demonstration for snakegame.py. Thank you for watching. Everyone have a good day. Goodbye.